Hi everybody, it's Dr. Eric Balcavage and we're back for another edition of Thyroid Thursday. Today I want to clear up some confusion about this thing called thyroxine binding globulin. So I want to explain what that is. Sometimes I get patients who are confused about what that is. Is it related to Hashimoto's and thyroglobulin antibodies? Even doctors get this confused at times. We'll ask them to run thyroglobulin antibodies and they will wind up running thyroid binding globulin. So let's talk about what thyroxine binding globulin is, and it should probably be just called thyroid hormone binding globulin. But it's not thyroglobulin. Thyroglobulin is the precursor to T4, T3, the thyroid hormones, and is found within the thyroid gland. Thyroid binding globulin is a protein that actually binds thyroid hormone and carries it around the body. Think like a taxi cab. It escorts or binds to the thyroid hormone, T4, T3, that's released from the thyroid gland and escorts it around the tissues, okay? It is not what thyroglobulin antibodies attack in Hashimoto's. Thyroglobulin antibodies actually attack the thyroglobulin, which is in the thyroid gland. Thyroid binding globulin made in the liver, thyroglobulin made in the thyroid gland. So essentially it's a carrier protein for thyroid hormone. T4, T3, it actually also can transport reverse T3. It's the primary transport protein of thyroid hormones. There is two other ones, thyrotin and albumin are two other molecules that are in higher concentrations in the serum that can bind T4, T3, reverse T3, but they don't have the same affinity, the same attraction form. So thyroxine binding globulin is the primary carrier hormone. About 75% of the T4, T3 in your serum is transported around the body by this TBG, okay? What are the functions of thyroxine binding globulin? Well, it safeguards the body from fluctuation. So when the thyroid gland makes T4, T3, it releases it into the serum. These binding globulins and proteins bind to T4 and T3 and escort around the body, but it also has a capacity to hold on a certain amount of thyroid hormone, and that's great. If there's a short-term situation where there's too much thyroid hormone, the thyroid binding globulins or thyroxine binding globulins can bind that extra thyroid hormone so we don't have symptoms of hyperthyroidism. If there is too little thyroid hormone being produced by the gland, like for some reason there's a short-term underproduction of T4 and T3, there's the thyroxine binding globulin can release the T4 and the T3 that it's carrying, and that can support at least short-term thyroid hormone levels until the thyroid gland starts making sufficient thyroid hormone again. The TBG, we'll just say TBG because that's what we abbreviate it as, reduces the loss of iodine. So it's thought that the TBG, thyroxine binding globulin, helps preserve iodine so we don't lose as much. The third function is it supports the uniform distribution of the tissues. So as soon as T4 and T3 is released from the thyroid gland, it's in free form. Once it binds to the TBG, it's now in bound form. And so when it's bound, the thyroid hormone can then be transported around the body, and then when it gets to cells or tissues that need thyroid hormone, it can be released. If it was all in the free form, we would probably have a lot more hyperthyroid feeling because that thyroid hormone that's free is able to immediately transport across cell membranes and be converted into T3 if it's T4, or if it's T3 that's being released is active right away. So we don't want tons of free-floating thyroid hormones circulating in the serum. We have it bound to these carrier proteins to kind of protect us, and we release it as needed under normal healthy situations. The fourth function of TBG is it's modifiable, and this allows for a targeted delivery system. So the body and the cells can modify the thyroid binding globulin or thyroxine binding globulin and change the conformation of it to either allow thyroid hormones to bind or for thyroid hormones to come off. And that way the cells and what's happening at the cellular level can really control the amount of thyroid hormone that's being released, becoming free, that can be transported into the cells, okay? There's a few things that can compete for thyroxine binding globulin or decrease the binding of thyroid hormones. Dilantin, salicylates, things like we typically find in aspirin. And then when there's inflammation, white blood cells can release something called human leukocyte elastase. And elastase can inhibit the binding of thyroid hormones. It actually changes the conformation of TBG so the thyroid hormones can't bind. That allows for increased levels of free T4 and free T3. Severe illness will decrease the amount of circulating TBG, and so therefore if there's decreased levels of these transport proteins, thyroxine binding proteins, then there's less availability for the free hormones to bind to these carrier molecules. So we'll have increased levels of free T4 and free T3. And that may show up as increased free T4 or free T3 in the serum, or it could show up as increased hyperthyroid symptoms. Now, if there's inflammatory mechanisms going on that are causing increased free T4 and free T3, those same inflammatory mechanisms may also decrease the transport of free T4 and free T3 into the peripheral tissues, so we probably won't get those symptoms. But we may see elevated levels of free T4 and free T3, and somebody may say, hey, well, you're doing great because you have plenty of that stuff. But if we see high free T3, high free T4, and there's inflammatory situations, it's probably because our thyroid binding globulin levels have decreased. Severe illness, we talked about that. Estrogen, whether it's endogenous, like there's an estrogen producing tumor, or there's certain types of moles that can actually produce excessive amounts of estrogen, or you can have excess estrogen because of hormone therapy, or because of birth control therapy, birth control pills. You could also have increased circulating estrogens as a result of GI infections and increased production of something called beta-glucuronidases in the gut, which kind of unwrap some of these estrogens that are supposed to be being detoxified and cleared through the stool. These beta-glucuronidases produced by bacterial overgrowth unwrap those estrogens. The estrogens can recycle back into the system, and those elevated estrogens can increase the amount of TBG. If we have increased TBG, the thyroid hormones T4, T3 will bind to the TBG, and then we'll have less free thyroid hormone floating around the body. Why is that important? Because only free T4 and free T3 is available to get into the tissues. So if we have estrogen overload, excessive amounts of estrogen, increasing thyroid binding globulins or thyroxine binding globulin, then we have less free thyroid hormone. And if we have less free thyroid hormone, there's less hormone to be able to get into the cells to stimulate our metabolism. So we could have increased hypothyroid symptoms and low free T4 and low free T3, and yet our total T4 and total T3 could be totally normal, okay? Androgens and anabolic steroids will actually decrease thyroid binding globulins. Androgens, like testosterone, actually work opposite of the estrogens. So if you have increased androgens or anabolic steroids, we'll have lower levels of thyroid binding globulin or thyroxine binding globulin, and therefore we'll have more free hormones. So that could actually increase metabolism. About a third of our thyroxine binding globulin is usually saturated with T4 and T3, so that leaves a lot of room or cushion for more T4, T3 to be bound to those tissues. At any one point in time, if there's an excessive amount of T4 or T3, there's plenty of room for the thyroid binding globulin to pick up that excess, so we don't have too much free hormone floating around the system. If these thyroid binding globulins are saturated, then we can start to see elevated levels of free hormone build up. Typically, if we look at lab work, and thyroxine binding globulin isn't often tested, the typical range that they look at on lab reports is about 1.1 to 2.1 milligrams per deciliter. I wouldn't worry about that too much. Just know that it isn't often run directly. Some docs will do it, a lot of docs will not do it. Matter of fact, in allopathic medicine, usually it's only TSH and T4. But you may see it on there, and if you do, just be aware, those are the ranges. many times docs will actually run a different test, which gives us a value of how saturated the thyroxine binding globulins are, and that's a test called a resin T3 uptake. And the resin T3 uptake is essentially a way to figure out how saturated the thyroxine binding globulins are. And that's probably information for another podcast, okay? So little wrap up here. There's something called thyroxine binding globulin. It's the major transport protein for thyroid hormones around the body. It is not associated with Hashimoto's disease in the fact that thyroglobulin antibodies are not produced against this. Thyroglobulin antibodies are actually against thyroglobulin, which is the precursor of T4, T3 in the thyroid gland. So when you have thyroglobulin antibodies, you're not damaging the transport molecules, you're seeing damage at the thyroid gland, okay? We also, with Hashimoto's, see TPO, thyroid peroxidase antibodies. So I think that wraps it up for today. What I'll do is next Thyroid Thursday video, I'll actually what I'll do is I'll explain thyroid binding globulin, this resin T3 uptake, and kind of help you understand what the lab values mean, so you're a little bit more familiar with it. But this is plenty for one Thyroid Thursday video. If you have any questions, put the questions below wherever you watch this video, or you can email me directly at my office at Chronic Condition Recovery Center, or you can reach out to me through the Thyroid Problems Doctor website. All right? Hopefully you'll stay tuned or see us for another Thyroid Thursday in the coming weeks. All right? Take care.